It's important to understand that determining clearance requirements hinges on correctly identifying the electrical equipment in question. Since the provided visual information does not depict a switch, we can't directly address the clearance distances specific to a switch. However, we can discuss general electrical clearance principles and how they apply to various types of electrical apparatus. Electrical clearances are crucial for ensuring worker safety and preventing accidental contact with energized components. These clearances provide a safe working space for qualified personnel to perform maintenance, repairs, and inspections. The National Electrical Code, or NEC, outlines minimum clearance requirements for electrical equipment operating at different voltage levels. These requirements are designed to protect workers from electrical hazards such as shock and arc flash. The specific clearance distances vary depending on the voltage, the type of equipment, and the presence of exposed live parts. For example, equipment operating at higher voltages generally requires greater clearance distances than equipment operating at lower voltages. Similarly, equipment with exposed live parts requires greater clearance than equipment that is enclosed or insulated. In general, the NEC specifies a minimum depth of working space in front of electrical equipment, as well as minimum width and height clearances. The depth of the working space is measured from the front of the equipment to the nearest obstruction. The width of the working space must be at least 30 inches of the width of the equipment, whichever is greater. The height of the working space must be at least 6 feet 6 inches or the height of the equipment, whichever is greater. These are general guidelines, and specific installations may have other requirements depending on local amendments or specific industry standards. Now let's consider some factors that influence the determination of clearance requirements. Firstly, voltage is a primary determinant. Higher voltage systems necessitate greater clearances to mitigate the increased risk of arc flash and electrocution. The NEC provides tables that specify minimum working distances based on voltage levels, typically ranging from 120 volts to several thousand volts. These tables take into account the potential for arc flash and the required distance for a worker to safely react and avoid injury. Secondly, the condition of the installation plays a crucial role. Is the equipment indoors or outdoors? Outdoor installations generally require greater clearances due to environmental factors such as weather and the potential for unauthorized access. Indoor installations may have more restricted spaces, necessitating careful consideration of equipment placement and working clearances. Thirdly, the presence of grounded parts impacts the clearance requirements. The NEC distinguishes between situations with exposed live parts on one side and grounded parts on the other side, and situations with exposed live parts on both sides. When grounded parts are present, the required clearance distances may be reduced compared to situations with exposed live parts on both sides. Fourthly, the type of enclosure affects clearance. Enclosed equipment, where live parts are not exposed, typically requires less clearance than open equipment with exposed live parts. The enclosure provides a barrier to prevent accidental contact and reduces the risk of electrical shock. Fifthly, the local codes and amendments can modify the NEC requirement. It is imperative to consult local building codes and electrical codes to ensure compliance with all applicable regulations. Local jurisdictions may have stricter clearance requirements or additional provisions that must be followed. Let's consider some examples to illustrate how these factors influence clearance requirements. Imagine a 480-volt motor control center located in an industrial setting. The NEC would specify a minimum working distance in front of the equipment based on the voltage level and the presence of exposed live parts. This distance would likely be several feet to provide adequate space for a worker to safely operate and maintain the equipment. Another example involves a 120-volt lighting panel located in a commercial building. The clearance requirements for this panel would be less stringent than those for the 480-volt motor control center due to the low voltage level. However, the NEC would still require a minimum working space in front of the panel to allow for safe access and maintenance. Now let's discuss some common misconceptions about electrical clearances. One common misconception is that clearances are only important during maintenance or repair work. In reality, clearances are important at all times, even when the equipment is operating normally. Adequate clearances ensure that workers can safely access the equipment for routine inspections or troubleshooting without being exposed to electrical hazards. Another misconception is that clearances are only necessary for high-voltage equipment. While high-voltage equipment does require greater clearances, it is important to remember that even low-voltage equipment can pose a shock hazard. The NEC specifies minimum clearance requirements for all voltage levels to protect workers from electrical injury. Another misconception is that clearances are only a recommendation, not a requirement. In fact, electrical clearances are legally enforceable requirements that are outlined in the NEC and other applicable codes and standards. Failure to comply with these requirements can result in fines, penalties, and even legal action. To ensure compliance with electrical clearance requirements, it is important to follow a few key steps. Firstly, consult the NEC and other applicable codes and standards to determine the specific clearance requirements for the equipment in question. Secondly, carefully plan the layout of the electrical installation to ensure that adequate clearances are provided. Thirdly, train workers on the importance of electrical clearances and the potential hazards of working in close proximity to energized equipment. Fourthly, regularly inspect electrical installations to verify that clearances are maintained and that no obstructions are present. Fifthly, document all clearances and maintain records of inspections and maintenance activities. In summary, electrical clearances are a critical aspect of electrical safety. By understanding the factors that influence clearance requirements and following the steps outlined above, it is possible to ensure a safe working environment for qualified electrical workers. Always consult the latest edition of the National Electrical Code and local amendments for the most up-to-date and accurate information on electrical clearance requirements. Remember that proper planning, training, and maintenance are essential for preventing electrical accidents and injuries.